This is Day 11, Lesson 5, Literal Equations. The objective in this lesson is that you are able to rearrange an equation for any variable that might be in the equation. So literal means related to or being comprised of letters. A literal equation is an equation with most or all letters or variables. Solving a literal equation is a way of taking an equation, a lot of letters, and solving it by isolating for one letter in particular. Oftentimes literal equations are formulas, like in geometry. A formula is an algebraic expression relating to or more quantities. For example, the formula for area of a triangle, area equals base times height. So there's a relationship between the rectangle's area with its base and its height. The formula for volume is volume equals the area of the base, that's why there's a capital B there, times the height. And the formula for distance is distance equals rate times time. You do not need to memorize these three formulas. We're just going to use them as examples. You will see literal equations throughout most of geometry and some literal equations in ICP as well. By definition, a variable represents a number. Therefore, and this is key, that the variables have the same properties as numbers. So I'm going to demonstrate four examples, or a couple examples here, of how to solve a literal equation. By doing so, I'm going to compare it to equations that you're used to or familiar with. So let's take a look at the first example. And maybe I can expand it for you so that we get a close-up shot. Okay, if you remember when you were solving one-step equations that you had here we have our variable term. I'm going to go ahead and draw a circle around our variable term, our constant, and you had a constant over here, and that let us know that we needed to combine our like terms. You needed to bring it over as a -3, right, to move it over. Take a look at on the right hand side here. Here we have two variables equaling another variable, and the directions say to solve for A. We're going to use that as like our MVP, our most important variable. Let's find that A in the equation. So what the question is asking us, they want us to get that A all by itself. Almost treat it like it's the variable term, like in our previous example, and treat everything else almost like they're constants. I know the variables are different, but we're going to treat them like they're constants, that they're variables. So if our job was to isolate that A variable, or to get it by itself, look what's with it, a positive B. Well, how did we get the +3 before to go over to the other side? We subtracted it, didn't we? Same thing you would do here. We would subtract the B, so minus the B. When we move that term to the other side, we change that sign. So it crosses off. Let's see what we have left. Now, when you have a regular equation that's not a literal equation, we can combine our like terms. 5 and -3 is +2. But with literal equations, you probably are not going to be able to combine any of the terms. Sometimes, but usually not. So you just have to rewrite the problem. A is equal to C minus B. And that would be your final answer. Let's try another one. Right, in our next example, we have x over 4 is equal to 6. Look where, this is our variable term, here's our constant. So our 4 is a coefficient of x. It's under it, so what do we have to do to move it? We have to move it up and multiply, don't we? Because the opposite of division is multiplication. Same thing here. The question says to solve for A. So again, A is our very important variable, but we have this B that's under it. So how are we going to get rid of the B? Well, we multiply it by B. Multiply it by B. So when you multiply by b, the b's cancel, and you have a is equal to, I'm going to write bc because normally when you show multiplication of variables, two variables together, you write them in alphabetical order. I could have wrote cb, and it does say the exact same thing, that you're multiplying those two variables together, and I would count either one of those correct. You're using the commutative property, so either one would work. Let's try this with some two-step equations now. So on my left, I have a two-step equation that you should be familiar with. Oops. Try that again. So in this two-step equation, we have two steps because here's our variable term, our constant, and our constant. And what did we have to do first? We had to combine our like terms, right, or move our constants. So you brought that -7 over as a +7 to combine your like terms. And you were left with the 3x is equal to, and you could combine, in this case, 2 plus 7 is 9. Then you notice you had a coefficient next to your variable, that 3. If it's beside it, you have to divide it, right? So we divide both sides by 3. X is equal to 3. Let's look at a literal equation now. In this next example, it asks you to solve for b. It wants you to get b all by itself. So that's our, we'll call it the MVP, the most important variable. Let's circle the term that it's in, and then put squares around all the other terms in the equation. Look familiar now? What would you have to move first to get that b all by itself? How about the c? We bring the c over as a plus c. You could either write it under or beside it, but in any case we're moving it to the other side by adding. So what we're left with now is AB is equal to D plus C. We can't actually combine them because they're not like terms, so we just write D plus C. The next step, and remind ourselves that we are trying to isolate that B, is to get rid of the A that's beside the B. If it's beside it, what do? We divide it. So we divide both sides by A. Now, this is tricky. Some teachers will say just do this to write A, and that's perfectly fine. So your final answer would be B is equal D plus C over A. And the reason why we have to draw that great big line is because we have to divide the whole other side. Normally we're combining whatever those two numbers would be and divided by A. But in this case we have two values that we have to divide each of them by. Because we have to divide every term by A, I'd recommend you writing it this way, and this will gear you up later on when we get into another unit. Is that you take D divided by A plus C divided by A. So you divide each term by A. Just don't draw the great big fraction bar. So this is an okay or good answer, but this answer is better. Okay. Our next example, it looks like you have a complex fraction. So what happens when you have complex fractions? Don't you have to cross multiply? So -4 plus n is equal to -1 times 6. The same thing will go here for our literal equation. We're trying to solve for A. So there's our very important variable. We have the 7 that's under it as part of a complex fraction, so we need to move that 7 to the other side with multiplication. So you would write 7b is equal to a plus m. We're not done with the problem because we still have to isolate that variable. I'm going to change pen color so you can see my next steps. So on our example problem, the familiar problem you were with, you'll have -4 plus n is equal to -6. We can multiply those out. And what was the next thing you needed to do? Well, we need to move that 4 over as a plus 4. Let's take a look. Does that look familiar? Here's our very important variable that we're trying to get isolated. So what do you need to get rid of? Well, that m. It's a positive m on this side, so to move it to the other side we have to subtract m. So our final answer would be A is equal to 7b minus m. You could have put negative m plus 7b, but generally we'll write the term with the letter in the alphabet that comes first, and then A. Now I would recommend flipping this around and write it in what we call standard form. A is equal to 7b minus m. You could just turn that whole equation around. It is still saying the exact same thing, but it's just not natural, what we call standard. The reason standard, think of it like this. If I said, my name is Stacy, everybody's used to hearing that. But if I said, Stacy is my name, am I really saying anything really different? No, we're just not used to it. It's not natural. Same thing with standard form and other forms that are equally correct. It's just not widely accepted. So normally the variable that your answer or you're trying to solve for will write on the left and everything else goes on the right. Let me show you two more, or one more example here. This is another example of two steps because we have a variable term and a constant and a constant. And what makes it two-step is that our variable has a coefficient. So you have to first remove the constant and then the coefficient if you're trying to solve for A. Here in the directions it says solve for m. Here's our m. So this would be like a variable term here if we were trying to get that m all by itself. All the other terms almost act as if they were constants. So putting those squares around helps to see what you need to do. In this example here, we'd have to combine our like terms by combining our two squares together. So minus 3. Here we're going to sort of, in a way, combine our like terms or move the square over as a negative r. So you have MA is equal to S minus R. A, our very important variable, is still not by itself yet. We have this m that's beside it. So what do? If it's beside it, we divide it. You divide every term by m. So those m's cancel out. So A would equal S over m minus R over m. If you had on your paper A is equal to S minus R over m, we would accept that as a correct answer as well. This is just the better answer right now. Literal equations are generally harder for students. They want lots and lots of practice, so we're going to keep on doing some more examples. But as I work each one, go ahead and push pause and see if you can read it and figure it out yourself, and then check with me. Alright, so the next one says the formula for kinetic energy is E equals mv squared over 2, where m represents the mass and the object, v represents the velocity, and they want to solve the formula for m. This looks like a typical question you're going to have in classes like ICP. So what you're solving for is the m. That's the most important variable. Let's rewrite the equation a little bit bigger so that we can see it. E is equal to mv squared all over 2. And we need to solve for that m. I'm going to go ahead and find it here. There's our m right there, our very important variable. And with that variable, not added or subtracted to it, but right beside it and under it, I have a v squared and a 2. You could almost treat this like it's complex in a way, or actually we'll just treat it like those are coefficients. The 2 and the v squared are coefficients to that m. So which one do you have to move first? Well, under, up, and multiply, beside it, divide it. We have to get rid of that 2 first. It's under, so we move it up and multiply, so 2e is equal to mv squared. You're still trying to get that m all by itself. So let's move that v squared all together. You're going to divide, it's beside it, so we can divide. It doesn't matter if it's beside it on the left or the right, but it has to be right next to it with no pluses or minus signs. So divide by v squared, divide by v squared. V squared cancels. Now I can put this 1 bar with a v squared underneath it. I would not write v squared under the 2 and v squared under the e because 2e is all one term. Remember, terms are separated by plus and minus signs. So your final answer, I'm going to go ahead and flip it around for us. M is equal to 2e all over v squared. Let's look at the next example. It says solve for c. Let's use that method again. Find that very important variable, the one that you're solving for, and underline it. Put a circle around it and any variables or numbers that might be directly beside or underneath that variable you're solving for. So I'm going to put my circle around the a and the c. Draw your squares around any terms other than the term that has the very important variable. That will help you to isolate your c. So we first need to combine our squares together. So we have this k that needs to move over with the j. You have j plus k, remember to change the sign, equals ac. That a is beside the c, so what we'd have to do is divide. If it's beside it, divide it. So your final answer would be c is equal to j, instead of plus k, all over a. That's perfectly fine, or you can also even write j over a plus k over a is the same thing. I'm going to have to erase some and move some up to have enough room. Well, maybe not. Let's try it. The next example, solve for p. There's our very important variable, but I see this complex fraction, so I need to get rid of the complex fraction by taking the cross multiplication. 4 times the w, so 4w is equal to a plus p. There's my p variable. That's like my variable term. And here's my other terms. I need to combine them together, so I'm going to move the a to the other side by subtracting a. 4w. Why subtract? Well, that a, if you don't see a sign, is positive. So the opposite sign would be negative. So 4w minus a is equal to p. And your final answer, if you want to flip that around, is p is equal to 4w minus a is the same thing. Alright, last two practice problems. Then you'll do page 5 on your own, or if you're in a class with your partner or group, and then check it with the next sheet or the next attachment. So this next question says to solve for c, look for your variable c. There it is right there. It has an a beside it and a k under it, so I'm going to circle all of that. Everything else gets squares. So I first move my squares, so I can have my circles on my left and my squares on my right. Ca over k is equal to s minus e. All I'm doing is rewriting it. I need to get that a out. I see a c beside my a and a k under it, so then what do I need to move first? That k. I move it up and multiply so that the k's cancel up. Now, when I multiply it to the other side, I have two terms over there. I need to multiply that to both terms. You can either write the k in front of the parentheses or after it, but you must have those parentheses because the k is being multiplied to both of those terms. And then, so let me write down what we have now. Ca is equal to k times s minus e is the same thing. We have a c that's beside the a because we're trying to get the a by itself. So divide by c, and then divide the whole thing by c. This right here is your final answer. You can leave it that way. Be careful. A common mistake that I see students make all the time is in that last step. Let me do this right here. They accidentally do this. What's wrong with this? Do you see what's wrong? I'm doing this incorrectly just so that you don't make the same mistake. Oh, wait a second. No, I made that same mistake in the last step. Okay, so the last things when I said that was the final answer, I made the mistake because look what the question's asking for. See, I did it too. The question said to solve for C. So I was accidentally dividing both sides by C before, and that would have gotten my A all by itself. But the question asked to solve for C. So yes, this is actually the correct answer. I made the mistake before. I divided by the wrong variable. See, it's so common, even I made the mistake. Last example, I'm going to have the race so that we have some room to do it. I will rewrite the answer up here, that way if you need to look back and see what the correct answer is, you have it. I just don't have all the steps though. Okay. So the next question says to solve for C. We have that complex fraction again, so you need to cross multiply the t. C plus A is equal to ST. Remember, when you're showing multiplication of two variables, all you have to do is write them side by side in one another. C is our very important variable. We got this A that's being added to C, so we have to subtract the A, so minus A. To get it to the other side. Our final answer then is C is equal to ST minus A. Alright, go ahead and do the group practice now. This is the end of this lesson.